Hello, everyone. Welcome to this BAKERpedia seminar, all about flour quality. I'm Dr. Lynn Carson, your host for today. This seminar is brought to you by KPM Analytics. KPM Analytics supplies instruments that measure critical quality parameters of incoming ingredients. They analyze products during the baking process and ensure final product quality. Their comprehensive range of analyzers are used by food producers like yourself throughout their production to improve efficiencies. It is also used to ensure quality and, to protect your brand as well. KPM Analytics is backed by 100 years of experience developing advanced products and processes for quality assurance and process control in baked goods manufacturing. Today, we are joined by Lena Boskburn. I'm excited about Lena because she's such an expert in this field. Lena Boskburn has an education in engineering and food science. She specialized in the cereal foods industry. She worked for Chopin Technologies, and she's been part of the KPM Analytics team since 2014. For the last 9 years, she has occupied different positions, and she now manages the food, products, and applications team. Her main role consists of ensuring the application development and the promotion of Chopin products. They provide personalized solutions to customers willing to improve control of their products and processes. Lena's responsibilities also include the standardization of the development method, working closely with various associations such as ISO, AACC, and ICC. Well, I'm so glad you're here today, Lena. So often we have guessing games happening on the production floor. And it's like, what's wrong with this bread? Why is it having blisters or white spots? And maybe we're not adding enough water, or is it a flour quality issue? Well, I think everybody here attending today will learn something from you on how we can stop guessing these games and to approach every problem objectively. So Lena, can you please share your presentation today, and we will learn how to objectively measure bread and better define flour quality.
Well, thank you, Lynn. That was a very nice introduction, and I hope I am up to the expectations now.
Oh, definitely you are. I know your capability, so don't hold back.
Okay, that's nice. Well, in any case, thank you, and thank you everyone for joining us today. Thank you, BAKERpedia, for giving us the possibility of doing this presentation. So let me start and share my screen. Is everything okay? Perfect. Okay, so a little heads up, the presentation of today is not a very highly technical or scientific presentation. The idea is more to discuss about some observations that we have made in the recent years, visiting bakers, visiting millers, professionals such as yourself, and discussing with them about their common problems, let's say, common difficulties or challenges. And the idea is also then to suggest a new approach towards quality control based on one keyword that would be objectivity. So I will start the presentation with just a little bit of history about the milling and baking industry, just to give a little bit of context. We have to realize the importance of the changes that we have lived in 100 years. Just 100 years ago, if you considered well, those two pictures here of a milling, an industrial milling plant here, or an industrial baking plant those are completely different to what we know today. Here, just the baking image would be more considered a craft bakery, but with just a lot of bakers inside today. And within the years, with the evolutions, we have seen the use of roller mills being more and more important at the milling level, and at the baking level, we have seen the development of more and more sophisticated tools, mixers, dividers, laminators, ovens, and so on. Up to today, where we really can count on a level of automatization that was never seen before, both at the milling and at the baking plant and at the baking plants. But the idea is here, 100 years ago, there were a lot of people managing all of that, and today's less and less people can be found on those plants. So we really have gone from really artisanal craft know-how to strong industrial challenges in a short amount of time. So what does that tell us? That tells us that yes, we have seen an evolution that was spectacular, but most of the tools that we keep using for controlling the quality of the flours, they were developed 100 years ago. If we speak about the farinograph, if we speak about the alveograph, those were equipment invented 100 years ago at the time where the wheats were very different, where the industry challenges, as we have seen, were completely different. And those tools, they were mostly used by millers, mostly to help better understand their flours and to ensure consistency, not necessarily to produce the most adapted flour for one specific baker, because bakers could actually count with master bakers able to correct if the flour was not fitting perfectly the process. They had this expertise to know how to adjust the hydration, how to set the proofing time or the oven temperature in order to always make a good final product. At the same time, we have seen that the baking industry is becoming more complex, more automatization, but also there is a lot of pressure on industrial bakers to adjust, to innovate, to address new markets and new requests from final consumers, such as gluten-free, low carb, keto, and so on, whole wheat flour. So there is a strong need to process a lot of different products and also to count on a lot of different raw materials, also enzymes that were used more and more over the last century. And finally, consumers are also getting more and more demanding and more visible. If I buy a product in the supermarket and I don't like it, I have the possibility to go on every social media and share my opinion. And this opinion will be highly visible. So we have more and more impact, and bakers have more and more pressure to always deliver a high quality product. And this situation is becoming less and less sustainable. And this is very well illustrated by a few facts. So the first fact is that traditional parameters can be misleading. If you open every baking book, go to check the literature, or if you even ask ChatGPT what is a good flour quality, then you will always find protein content to be one of the most important indicators. If you just take this example here, baking business says that to make a good white sandwich bread, then you need a flour with a protein content between 10 and 11.5%. So that looks simple enough. And that would be great if it could work. But the truth is it's not that simple. We have made a study a couple of years ago where we analyzed 150 wheats. We have milled them and analyzed them for protein content and for bread making capacities. And what we have observed is that you can actually have two very similar flours in terms of protein content, here 10.1 and 11.1%, which is in this range, and still end up with two very different breads. So I'm not saying that protein is not important. I'm just saying this is just one piece of the puzzle and not the entire picture. Then another fact is that between the flour and the final product, there is a lot of variables. There is the process. There is the entire process. And when we consider the final product, also, we should consider what is a good final product. And we realize that this notion really depends on cultural habits, on users' preference. If you go to Chicago and ask for a good pizza, it will not be the same pizza as a good pizza from Napoli. Both pizza are good, but they are just not the same. So there is that, and then there is the process. There is the specific formulas that you are using, the specific process that you are using, the machines, the temperatures, the human factors, of course. And all of that makes that basically flour quality should be specific to each baker, taking into account the process specificities and the final consumer preferences. And so when we rely on generalities, such as the one that can be found here in another document to choose a good flour for making pizza, considering the W of the alveo, well, if you take a W between this and that, you will have a good pizza. Well, this kind of advice, they are good generalities, but they do not integrate the differences between each blend. So they do not really correspond to each baker's reality. Another important fact that is becoming more and more true since COVID is that the expertise is gradually leaving the baking industry. We see more and more expert bakers retiring and a lot of difficulties to replace them because the young generation does not coming into the market, into the job market, they don't necessarily want to spend 10 plus years to specialize in one specific process working in a dusty, noisy environment. So this expertise is leaving. People knowing how to react, what to do, are getting more and more difficult to find. And then a final fact, maybe the most revealing of all of that, is that, well, we did a recent LinkedIn survey where we asked a very simple question. Does it happen that flour, despite meeting all laboratory specifications, still gives issue during baking? And 96% of the answers were yes. Yes, we still have issues despite flour being between the certificate of acceptance. And this can go actually for 25% of people who answered. This is a problem that happens more than 1 out of 10 flour deliveries. So that can cost a lot financially and worst case scenario in terms of brand image as well. Interestingly enough, the 4% that says no, it never happens, when we looked up who they were, what they do, they were mostly academics, so very theoretical people, not working in the baking plant every day. So this very well illustrates a gap between the theory and the reality that needs to be understood. And here, to understand it, we really believe that we need to consider the specificities of each process, of each formulation, of each baker's reality. It can be seen as complicated because of the diversity of those processes, of the final product, and so on. But it actually can be very easy if you simplify the process, if you think of the process in 3 key transformations. Because whatever process you consider, whatever final product you do, you always must mix flour with liquid, because we don't eat raw flour, that's not good. So you make a dough, that's the first transformation. And then you need to cut this dough into smaller pieces, because we don't eat 500 kilograms or pounds of bread at the same time. So you cut it into little pieces and you shape it in a shape that is more aesthetic and that will also help with organoleptic qualities. So that's the second transformation, shape the dough. And then finally, you need to set the final shape of the product. So that's the third transformation, and all of that makes the process. And basically here, what we suggest is to do a little bit of reverse engineering, going from the final product to the flower and thinking at every step, what is actually important here and how do I measure it? So this is what we are going to do, starting with the end product. Whatever is the final step to set the final product, it can be baking, steaming, frying, freezing. After this step, the final product is done. So it must have the characteristics expected by the consumer. So here it's important to define what makes this product unique and why would the consumer buy it? Is it the color, the size, the volume, the softness, the shelf life? But what is important for you and how do you measure it? And it's funny because when we ask this question to industrial bakers, a lot of times this is a visual inspection that is done at the end of the line by operators who will manually select the products that are non-conform and place it into the trash bin. But this actually rely on a lot of human factor, which can be highly subjective. Then another question is how much non-conform product you reject and why. Because if you know why, then you can react accordingly. So here, the key step is really to put objectivity on, to put numbers on what is a good product and how many you can produce. And to do that, you can count on vision inspection systems, such as the one produced by iPro System, which is a brand of KPM Analytics, which are doing both benchtop and also at-line equipment to measure many different characteristics. It can be the height, the shape, the symmetry, the color, and even the seed repartition on a bun. But by knowing that, well, you can quantify actually what is a good product, and such system can also be equipped by with automatic rejection system that tells you exactly how much product were rejected and why. So here you can put numbers on your actual process performance. And then you can go one step before. So from dough to shape pieces, you have a dough, you need to make it into a shape. So whatever the process you consider can be very simple or complicated, even such complicated as making bagels. It's actually mesmerizing to see the videos. If you have not, you can find some on YouTube. But we can easily understand that the characteristics of the dough here are very important. The consistency, the stickiness, the elasticity, the extensibility, all of that makes that you will end up with a good final product. And if you consider the leavened product, then you need to add an optional step, which is proofing. And here you also need to consider some other parameters such as gas retention, porosity, stability during proofing. So basically here, we also have keywords that we need to identify as important for us. Bakers are talking about stickiness, about elasticity, about all of that. So what are the most important for you and how do you measure it? And then another step backwards from flour to dough. Then you have a flour, you mix it with water and generally with also other ingredients. And you place all of that into a mixer, many different kinds of mixer that you can consider, and you will make a dough. And this dough processing, the quality of dough that you are making here is critical for the rest of the process and for the final product characteristics. If it is good, then you have every chance to have everything going well and have a good final product. If it is not good, then it can have a huge financial impact. So if the dough is not good at this point, there is always the possibility to rework some of this dough. This is a very common thing that is used by bakers to retake some dough that is not working well and replace it into the mixer with some new dough. It can be done to some extent, but it also it is not so good for quality because it will contaminate the new good dough. So here at this step, the question is, again, how do you control the quality of the dough at this step? And most of the time when we ask these questions to industrial bakers, well, they have this master baker, this expert at the line who is touching the dough and evaluating its properties and knowing how to adjust if it's not good. But again, those people, they are disappearing. And this has been confirmed by many bakers. And of course, you need to ask, how do you control also your raw material? So here the idea, whatever you are trying to measure, the idea is to remove subjectivity from the process and to put numbers into it. And to do that, well, KPM can really provide an entire solution working at every level of the baking plant. First, by controlling the final product, by making sure of its visual characteristics, the color, the shape, the symmetry, the seed repartition, and so on. And also to reject, eventually to reject the products that are not good and to be able to understand why products are not good, to be able to efficiently react. Then we can go one step further, analyze the dough from the line, take a piece of dough from the line and place it into an equipment such as the mix lab that will be able to characterize the consistency of a good dough, to put objective data on historical expertise. And then, thanks to the same tool, you can build specification based on what is good for you and give it to your millers. So the idea here in conclusions is that there is a traditional way of making quality control. And basically this is to make a lot of different tests on the flour, to test the flour with farinograph, alveograph, folding number, glutamate, to measure its protein content, its ash content. And we do all of that. And we hope that somehow the final product will be good. And most of the time, we also rely on a flour expert, on some kind of flour guru that will tell you, yes, in the literature, you can find this information, or I have made this test. And so I tell you that because this flour has such characteristics, then it is good for you. This model actually results in 96% bakers still declaring having issues, despite all of those controls. So the modern quality control in which we believe is to guess less, predict less, and measure more. Start measuring the process actual performance with vision equipment tools, understand how the recipe and the process impact the final product, and define dough characteristics and full consistency of the dough thanks to instruments such as the mixer lab. Define the best flour according to the process, according to what you have actually observed, and then give millers those specifications that were based on what is actually good for you. And this is actually a model which can really benefit bakers, but also millers, because then the millers, they have not an objective based on common knowledge, but something that is based for you. So they don't have to waste time and plenty of analysis that they are not really useless because they don't tell the entire information. So the idea here is what you can measure, you can improve. And with this system, you can actually measure your entire process. And another upside is that you will have objective data at every point of the process. And data is the food of artificial intelligence, which can be considered as the future in the field. So I hope I'm in time. Thank you for your attention. And of course, if you have any questions, I will be more than happy to try and answer.
That's an excellent presentation, Nina. Thank you so much. I think we have a lot of questions on how are we going to relate the final product quality to, flour and dough quality. So let's all go to the question and answer session where whoever's on here, please go ahead and put in your questions and we will go from there.
This is an interesting question, I think partially answered by the presentation, by the fact that most of the time the process is not taken under consideration, but also by something that, well, by the fact that today flour quality really relies around protein. We control protein quantity, we control protein quality thanks to farinograph, extensograph, alveograph, glutamatic, all of those instruments, they measure protein. But the fact is that 70% of the flour is in starch, and starch is highly functional and is not measured by those kind of devices. The Mixolab that I was mentioning is actually measuring during the same test the protein and the starch quality. So I think that by considering the starch, bakers would have a lot more chances to also have compliant flours.
Right. And don't forget, nothing is really consistent on your Miller side of things as well. All it takes sometimes is your main miller going on vacation and someone taking their place, and then keep a close enough eye on the process and just basically let a different quality flour go through. So this is part of the reason why sometimes, I'm not saying all the time, sometimes you just can't trust COAs. And it's always a good practice to make sure that you test your flour, if it's not for every batch sent to you by the mill, at least once or twice a week, just to make sure that it falls within COA, right? And don't forget, if you don't check, they know that, and you will probably not get the quality that you bought for. So checking flour quality is instrumental and really important in your flour receiving procedures.
Well, yes, this is actually the simplicity of it, is that you can consider whatever final product, and whatever final product you will have some important characteristics, visual or organoleptics, but you need to define what are those important characteristics, and you need to just observe what is a good dough making those right final products with the good characteristics, and what is the flour leading to a good dough leading to a good final product. So it is just about observing, and that works for any kind of product, yes.
I agree. I agree. And if you don't have a visioning system already in place, I would highly suggest getting one and to start collecting data from there. And just work backwards. So for example, if all of a sudden you're seeing blisters, quantify the blisters on a visioning system, you can easily do that. And then look at your data, correlate it to the incoming flour data. And if you don't trust that data, we would have a separate conversation altogether. But say you trust that data, then you should be able to see a correlation either in falling number, either in starch damage, or either in protein quality and quantity to the blisters on the bread. I know this may sound like a very big thing to do, big thing to accomplish, but you have to start somewhere, because I don't think most bakeries have a choice anymore. We're losing talents like crazy. So my suggestion is start today to figure out what causes your end quality to fluctuate, and the best way to look at it is start correlating your end quality to incoming flour quality.
Yeah, and the interesting part of it is with such system, if you measure the final product and measure the dough at different steps, at different key steps of your baking process, and then your raw material quality, then you have the complete picture and you know exactly when a deviation happens. And so
Right.
you know what to target to correct.
Correct. Very good. Good point, Lena.
It's very difficult to answer again, because it will depend on each use of the equipment. But just to give how the instrument is used, and the instrument can be used at many different levels. If we speak about the mixer lab, for instance, if you use it to actually quantify how much water you should put in your dough to reach a certain consistency, which is a critical parameter for bakers. Most of the time, we need to maximize the amount of water in order to make more bread and with less flour, less money. Then the amount of water that you can put without impacting the quality of the dough is critical. And by using the mix lab, we have made experience where we have pushed up the level of water by it was 0.5%. That was not much, but that was the same whatever the operator. And that gave the possibility to make a lot more bread, more regularly, more constantly. So again, I don't have the information. The customer did not share it with us, how much money he gained, but this can be very fast. And if you
I
use
agree.
it at different
Yeah.
levels.
And it really also depends on the team. Is your team bought into this? Does everybody agree with your procedures? The faster the team buys in, the faster your ROI. For example, okay, say somehow you've been experiencing a lot of protein quality issue, and you put your protein quality on your spec, and you get your team's buy-in, and you get your millers buy-in, because I'm sure at that level you are constantly talking to your miller. If not, if not daily, it would be on at least twice a week basis, and you communicate that to them, and you say, hey, I'm seeing this on my mixer lab. It doesn't make sense. Could you please explain why? So once you have those conversations, you're going to have more buy-in from your miller side of things. Your millers will know that oh, wait, this baker is watching. I need to be watching my process really closely as well. So I don't know how to quantify the ROI on that one. That one is pretty immediate, but if you're having problems with incoming quality, and you're suspecting that the miller's not watching, and you buy an equipment like that, the ROI is almost immediate, and the ROI is measured in the consistent quality that the flour is coming in. So really, there's no monetary value on that. It's just, you're going to see consistency from the flour that's coming in almost immediately, and that's just been my experience.
Yes, absolutely. So we have a whole team of applications experts, application specialists who are on a daily basis working with customers from the beginning, from the definition of the project, the definition of the objective, the training, the experiment plan, making the tests, or assisting into making the tests, and in the end analyzing the results, providing the report. So even after the instrument is bought, we are there to answer questions. This is our job. So yeah, we can support our customers at many levels when it comes to such projects.
Well,
So
thank you, Lena. Yeah, I would like to add to that as well. It is pretty intensive project to really implement these quality parameters and incoming quality receiving procedures. But you only need to do them once, and you need to get the team's buy-in. I think that's the biggest thing, is getting the team's buy-in. And once the procedures are set, and KPM has all the knowledge that you need, and if you guys can't do it, then I'm more than willing to step in to consult on these. I've done several of these, and the biggest effort is upfront. Once you put in the time and effort to create your quality procedures upfront, it's going to be easy going forward. Maintaining it is so much easier than implementing it. So really get your team's buy-in, get the instrumentation. I think all the consulting that KPM can provide is going to help you implement these quality systems. And really, the end goal, and I would like to remind you, the end goal is to produce consistent, predictable, big quality goods. Okay. And that is your entire objective as a QA specialist, as a production manager, plant manager. It's like trying to keep up with quality that you can't sell, that's out of spec, that is unacceptable to your customer, just goes into the waste bin, so that's a lot to consider, and if you count the amount of waste, if your waste is about 3%, if it's bordering double digit, it's time to look into an incoming receiving quality standard. Okay. So thank you, Lena, for coming on today. I think this data collection, quality analysis is so necessary, and bakeries just need to look into this right now, because we're just losing the talents, and we need to produce methods that can be carried out at the bakery. So thank you for sharing your knowledge, Lena. And everyone, if you want to continue the discussions, we are available on our Facebook group. And this particular recording will be available next week. Thank you for coming.